he requested questions, we should give him some.
So why do you need to make a specific states file and just copy the information in the outcard? Why can't you just use this in the outcard?
Because the states file has certain information in it that it kind of specifies the state that it's in, solid, liquid, the state of matter it's in. So you need that to kind of, so the outcard or the program knows what you're dealing with. Does that answer your question?
Yeah, but like, why do we need to? Because that information's already in the outcard, right? We just copy it.
I believe most of it.
Most? Oh, is it not all?
Okay, I'm gonna be honest with you. I'm just gonna guess here and say that not all of it's in the outcard.
Okay. Fair enough.
Any other
Can
questions?
I help and comment?
Dr. Kelly, do you have any questions?
Outcard is very big file. It contains more than needed for simple guys like us.
Yeah.
And we need to focus on a small fragment of data, omitting the rest. Therefore, we manually carve this states file. Make sense?
Yeah.
So let's continue question section.
Can you go to the DOS chart, that one? So you have to input, I think this happened to me at one point, you have to input the range, the orbital energy, the x-axis, or does it do that automatically?
Are you talking about
Like you
this
have,
right here? This area?
Yeah, you have -10, like the limit.
Yeah.
Right? So like if you go back to like -15, you can still see some peaks.
Yeah, I don't think it matters as long as it's, far enough back.
What is the?
Yep. It's just kind of, it's your range on here, so like -10, but if you go to like -15, I don't think it'd show anything because, the plot doesn't extend that far.
But when you want to see this chart, you have to have an idea of what range your density of states are going to be in to input those right away?
Yeah.
Okay.
Or like a general idea.
I want to know.
Because I think you're looking for the gap. So like where the gap is.
What if there's like stuff at like 1 though, the gap that you don't see that?
I think you just use, general intuition that anions are pushed back farther, or the gap is pushed back farther, so
Yeah.
Kind of did know a little something about VASP.
Does it automatically scale the y-axis?
I think you, let's see. I think so. Yeah. Any other questions? Yeah.
A provocative question. Let's go to your first slide. Yeah, this one, second. So, lower right, just tell us what is shown. It looks like a little globe.
Well, you have your X, Y, and Z axis, and that's a picture of an atom with an atomic orbital around it, and little dots indicate an electron density state.
Are you 100% sure?
No, I'm not. Sounds good.
Okay, so why you showed X, Y, and Z axis? Why don't you show X, Y, and Z? Why there are KX, KY, and KZ?
That's the key points.
Closer, much closer. So instead of direct, instead of Cartesian space, which space do you point here? Which space do you show here?
I'm honestly not sure. I pulled this picture off Google, so.
Huh?
I pulled this picture off Google, so.
Yes. Well, Google has many nice things, and I'm very grateful to you for showing this.
This is spherical coordinate.
So what are the x's? Spherical it will be angle. So what letter K stands for? Just any guess. Do not hesitate.
Key points?
Yeah, yes, you've told it. But it's too advanced language. That's on the language of for simple guys. Like you can come on street and say, look, here's my key point.
I'd have to further explore that question.
Let's explore it right now.
Okay.
So, kinetic energy, what does it depend on?
Mass,
And?
velocity.
Yes. So instead of thinking of electron as something in the Cartesian space, one can forget about position in space and look only on velocity, where it is to the left, to up, or to the side. So 3 projections of velocity. And it becomes even more important than location in space. So it is a primary thing that creators of VASP code were thinking of. So those points, a single point on this plot, meaning an electron with a defined projections of velocity along x, along y, and along z.
So these axes are sort of just saying the velocity
Yes,
that
yes.
we could take.
Right. And if the electron moves with a constant velocity, then its position in this space doesn't change. It moves in Cartesian, in real space, but it stays in the momentum space. And as soon you stop talking to simple guys and you start to be in academic language, instead of velocity you tell momentum, and then you go to case planes.
Makes sense.
More questions? Okay, let's thank Austin once again.